All right, last example. The Walking Dead, the television series The Walking Dead is an American post-apocalyptic horror drama that is based on the comic book series by the same name. The first episode aired back in October 2010 and earned a 25% audience share. That is, 25% of all TVs in use during the showtime periods were tuned to the station airing The Walking Dead. It was very popular when it came out. Let's represent the number of people who watched The Walking Dead in a random sample of 500 people who watched TV during the period when the shows aired. So let me highlight something. I'm going to highlight my random variable, which is X, which is represent the number of people who watched The Walking Dead in a random sample of 500. The distribution has the mean of 125. So that is your mu. The mean 125, that is your mu. That is mu. And the standard deviation of 10. So that is your sigma. That is our sigma, right? Find the approximate probability that fewer than 220 people selected to watch The Walking Dead. So I want to know, so what does this mean? This means, maybe I'll highlight in green maybe. This means I want to find P of X is less than 220. Remember, probability of fewer than 220, so P of X less than 220. So let's draw some picture. So here is the distribution of the number of people who watch The Walking Dead. It has a normal distribution. And again, if it's normal distribution, you're going to fill out its normal distribution. N is mu comma sigma. Mu here is 125. Sigma is 10. And so mu is your mean, which is your average, right there in the middle, 125. I'm going to use black. Now, I want to know the probability that fewer than people, fewer than 220, I'll put it right there. Maybe someone else can do it right there. It's fine. It doesn't matter. So because I want X is less than 220, that means I want the probability cumulative from the left, right? So I want this. I want that area. Anything from the left all the way to 220. So the probability cumulative from the left. Well, in order to find the probability of P of X less than 220, I need to standardize my normal curve. So standardize the normal curve. Standardize. So the distribution is still normal, but now the mean and the standard deviation change, and it changing to 0,1. Any normal distribution, when you standardize, has the mean of 0 and the standard deviation of 1. Right? So mean is 0 here. Now, the number 220 corresponding to the standardized will be right here. Something here, which I don't know. Right? The x-axis will be your z. Down here, right here, the x-axis will be what? The number of people who was The Walking Dead, right? Over the standardized curve, the x-axis is actually your z values. Z value. That's your z value, right? And I want to know the corresponding z value of a number of the random variable 220. So let's use the formula. The formula is what? Z equal x minus mu divided by sigma. Remember, that's a standardized formula, right? You're gonna now you plug it in. So z equal x is 220, mu is 125 divided by sigma, which is 10. Turned out to be 9.5. So z is 9.5. So that question mark right there, that question mark right there is 9.5. Maybe I'll use red. Red. And that question mark right there is 9.5. And again, it's corresponding to this area in the standardized curve. And all you have to do is look up on the table. Well, you can do by hand or use calculator. I'm not a fan of calculators, especially come to statistics. Nowadays is big data now. In the real world, they don't use calculator anymore. Least you can do is use Google Sheet, right? Or some software you found on the internet. I'm going to introduce you one of the software to find the probability. By the way, so that's Z, right? So I want to know P, maybe I'll use green. I want to know P of X is less than 220. This is equivalent to, I want to know Z of less than 9.5. I'm going to standardize them. You look up on the table. By the way, for the Z value, in practical sense, is go from, I would say from -4 to 4, right? Anything beyond that would be stretching it. So anything beyond that, either 0, it has a probability of 0 or 1, depend which cumulative you find here. So Z in practical sense is go from -4. So here the left arrow go from -4 and the right arrow go to 4, right? Here we have 9.5. That's way out there, past 4, right? So if you want to cumulative the probability from the left, it looks like equal to 1 to me, right? But we can check it out with the software. So let me introduce you a software here. Let me share my screen. Let me share my laptop screen. Share. There you go. I think you can see it now. Am I sharing it? I think I am. All right. Let me go from beginning. It's called statist.com. It's free. It's come with the book the OCC use for statistics. So if you go to statist.com, you should see something like this. I want to know, so go to analysis, probability distribution, normal distribution, you know what we're doing. Enter one value, then click evaluate to find the other values. Now we know Z. We want to find probability area, right? So Z is 9.5. And here the default is the area accumulated from the left, right there. So here accumulated probability from the left, which is what we're looking for, is 1. Right? If it from the right, it would be 0, because literally there's nothing left to the right. Right? All right, that's it. Congratulations, you all finished at least the first chapter of the basic probability. There is much more. Thank you for listening, and hopefully see you next time.